Hi Sir Michael Pabustan, my name is AJ Kumar, BSAMT 2A student of University of Perpetual Health System Delta, School of Aviation. I'm here to discuss about the topic I choose, induction system of reciprocating engine. And so what is induction system? The induction system brings the air outside and mix it with fuel and delivers to the fuel air mixture to the cylinder where combustion happens. So what combustion create? So combustion create the thrust or power that our aircraft needs. So there are two type of induction system commonly used in smallest aircraft. The first one is carburetor system and the second one is fuel injection system. So in carburetor system, the carburetor system mix the fuel and air mixture before the mixture enters to the intake manifold for combustion. And it helps when our aircraft fly in high altitude, then the that time the pressure is going too down, and while the pressure is too down, then the fuel will remain constant even the aircraft is flying because of the rich mixture is are not fixed. So how carburetor system and fuel injection system work? So in carburetor system, the carburetor mix the air and fuel system before it enters into intake manifold for combustion. So while in fuel injection system, the fuel injection mixed immediately the air and fuel mixture before enters in each cylinder of fuel injection. The components of carburetor are air and fuel mixture, throttle valve, venturi, and discharge nozzle, air bleed, air inlet, float camber, fuel inlet and fuel, and the last one is mixture needle. So the components of fuel injection system is fuel line, fuel manifold valve, and auxiliary fuel pump, engine driven fuel pump, and fuel air control unit. Induction system is very important to our aircraft because it creates thrust or power. Without induction system, or if there is any problem in induction system, the aircraft could not be functioned. So this one is the example of non-supercharged induction system using carburetor. So the components are carburetor air valve, air filter, air intake duct, cold air actuator lever, drain line, temperature valve, and carburetor. So this the blue and red, as we can see, there are two arrows that represent. The blue one represent cold air, and this one is for hot air. So this area is out as ambient air. So when ambient air enters air filter, so the work of air filter is to clean the air and to prevent entering any dust or any particles in fuel duct intake. So there are different type of air filter like foam and dust, etc. So after entering the air intake duct, it's then the work of cold actuator lever is to allow the maximum cold air need when the process is ongoing. So we need both balance air, because we know that when aircraft is flying in high altitude, in especially in the aircraft use carburetor system, there are chance of icing in carburetor. So that's why we need hot air too. So the work of temperature valve is to maintain the temperature, or to test to know the temperature inside the. So carburetor, as I already mentioned, that the work of carburetors to mix fuel and air mixture. What is air scoop? Air scoop is located in engine molding, and it helps to allow the maximum airflow to induction system. So the next one is I will show you the video of some example of induction system of reciprocating engine, fuel injection system, and carburetor system.
In order to burn, the fuel must be vaporized and mixed with air at the correct ratio. This job can be performed by either a carburetor or a fuel injection system. A carburetor contains an open pipe with a shaped restriction, or venturi, inside. The venturi momentarily accelerates the intake air, lowering its pressure and temperature. A fuel nozzle placed inside the venturi allows the lowered air pressure to pull fuel through the nozzle and into the intake air. The sprayed fuel quickly vaporizes in the air. Next, the fuel-air mixture encounters a throttle valve inside the carburetor. The pilot manipulates the position of the throttle valve to adjust the engine's power. At idle power, the valve is nearly closed, greatly restricting the flow of fuel and air to the engine. At full power, the valve is completely open. Air is cooled inside the carburetor as a result of the reduced pressure and the vaporization of fuel. The temperature can drop from relatively warm temperatures prior to the venturi to below freezing just after it. Ice can form inside the carburetor, restricting the flow of air to the engine and reducing engine performance. A pilot can counteract the formation of carburetor ice through the use of carburetor heat. The carburetor heat control in the cockpit moves a valve which directs intake air through a small heat exchanger. The heat exchanger uses hot engine exhaust to warm the intake air. The use of carburetor heat will also cause an engine performance decrease. This is due to the air being thinned as a result of being heated. However, it must be used to counteract carburetor ice, since continued ice formation will further reduce engine performance. Favorable conditions for carburetor icing are temperatures below 70 degrees Fahrenheit with a high humidity, although carb ice is possible at temperatures as high as 100 degrees. A fuel injection system uses a fuel injection pump to supply fuel under pressure to a fuel-air control unit. This unit meters fuel and air to the engine according to the throttle and mixture control settings. The metered fuel then flows to the fuel flow divider, which splits the fuel equally among the cylinders. Each cylinder has its own fuel injector, which vaporizes the fuel just prior to the cylinder's intake valve. Since there is no venturi in a fuel injection system is less susceptible to internal icing. The high temperature of the cylinder makes ice not likely to develop at the fuel injector either. Both carburetor and fuel-injected engines are susceptible to impact icing, which results when the airplane flies through visible moisture that forms ice on the engine's air intake or air filter. This impact ice blocks the flow of air into the engine. To counteract impact icing, many engines include a manual or automatic valve, which provides an alternate intake air supply.
So there is a troubleshooting of induction system when there are some kind of problems in our induction system.
Hi, I'm Mike Koblich from Electro Air, and I'm with Ron Cooper of Cooper Air Repair today, and we're going to talk about induction leak tests. An induction leak test is a commonly misunderstood and overlooked engine diagnostic test, yet it can be a very effective tool in diagnosing major engine problems and helping to improve the efficiency of engine operation. We're going to talk today about some effective techniques for finding induction leaks on aircraft engines. Ron, what are some of the indications for doing an induction leak test, or why would we do an induction leak test in the first place?
Well, generally we perform these tests at 100-hour and annual inspections when the aircraft comes in or a customer complaint. It may be anywhere from a high mag drop or little or no RPM rise on shutdown of the engine.
Now, why would an unusually high mag drop during an ignition check or little or no RPM rise during an engine shutdown, why would that be a sign of an induction leak?
Well, when you've got an overly lean cylinder, you've got a situation where that cylinder is putting out less power compared to the other cylinders with a proper mixture in it. So when that cylinder is checked with the mags, it's going to make the RPMs drop even more.
Makes sense. Let's talk about the induction leak test itself. Right off the bat, safety first. Generally, you want to do this test with two people. That'll become obvious in a minute. Secondly, you want to make sure the aircraft is secured, the master switch is off, throttles and mixture control are closed, remove the spark plug wires from the spark plugs themselves, and anytime you're operating near the engine, always remain outside of the arc of the propeller so you don't get hurt, basically. Safety first. The equipment needed is a differential compression tester set to 80 psi and a soapy bubble solution. Any soapy bubble solution will work. Kids bubble bath in a spray bottle would be great. Ron, why don't you talk about the hookup of the equipment?
Okay, basically we use number one cylinder as general. You would start out with a differential compression test. And we bring that cylinder up towards top dead center on the compression stroke, and then we induce our air into it, and then Mike will hold on to the prop, naturally with both hands on each side of the prop, and you got to have communication between the two of you so he knows when the pressure is coming on, because these props can be quite deadly because of the force that this cylinder can put on that prop. Now, I'm going to hook up the differential compression gauge. Make sure your valve is turned off on your gauge so it doesn't put any air into it. Okay, Mike, are you ready?
I'm ready.
Okay, I'm going to turn the valve on, and then he's going to start feeling pressure build up in that cylinder. All right, Mike, why don't you move your prop so you can charge up the cylinder. Now what he's doing is he's allowing the cylinder to fill up with air. We're at 80 psi, and if you heard that, that's what we call burping. He'll move it in the opposite direction of travel for that engine, this engine. Okay, Mike, go ahead and burp it again. Okay, that noise you heard is the air that's filling up the entire induction system. This could be on fuel injection as well as carbureted engines. Okay, now what I'm going to do is apply soap solution with a sprayer that can be obtained to any hardware store. Okay, Mike, go ahead and burp it. Okay, if you notice there's bubbles coming out of this hose. Alright, that could be a loose clamp, or, there you go. That could be a loose clamp or a kinked tube that has been tightened too much by the clamp that you wouldn't even see. Alright, the next place that we're going to go is up on the gasket area where the induction tube bolts to the cylinder. That can be a bad gasket area or a misplaced O-ring. Okay, go ahead and burp it, Mike. If you notice, that blew a lot of soap solution away from it. This is a severe leak. However, if it was a small, low pressure leak, by putting too much air, when what we call burping it like you're seeing, it could blow the soapy solution away from it. So let me do it one more time. And then, okay, Mike, go ahead. All right, there's a major leak. That's going to cause a lean cylinder condition, mag check problems, shutdown problems, as well as cause excessive heat in that cylinder. Okay, Mike, we're done. Don't let go of the prop yet. I'm turning the valve off and disconnecting it so there's no pressure left in the cylinder. And then make sure move the prop so it relieve it, Mike, just in case. Okay, that's it for the induction leak test.
So just to review, on the induction leak test, always make sure the airplane is safe and secure, master switch throttles, all that equipment turned off. Do this test with 2 people. Check for induction leaks. Common checkpoints would be loose clamps, induction tubes, rolled seals on induction intake tubes, throttle shaft, loose carburetor, fuel injection servo. I hope this video has been helpful. For Ron Cooper, I'm Mike Koblik with Electro Air. Happy flying.
So that are the few things I know about my topic, and sorry for that. Sorry, sir, for my mistake, and God bless. Mag-ingat kayo, sir.